It's all jokes. Thank goodness. I don't know. Anybody else here has a hard time staying awake and talk, so I'm going to try to help us all get along. But I'll start the timer so that she doesn't have to come get me. I'll do a better introduction on the next slide. But Meridian Studios is a co-development studio that we run, along with a rather large partnership with a couple of consulting firms and things that we work with. So we're going to give you, to start with, at least a little bit about who we are and why you should bother listening to us when we talk about AI and why we have a perspective and what that perspective is. But yeah, Barracks is our approach to doing manual testing using AI. I will get into the architecture that's there. I won't show you any code from my inference layer. It's the only thing that keeps me in a job, and we're all worried about that. So to move on there, I'll just give you a quick overview. We're going to start, like I said, with some of the personal company information, our perspective on AI in general, the design and implementation of Barracks as what it does, and then last, I'm presuming what you actually want to know after everything else, and then the results, whether it works or not, and then you can all go eat something. So to start with, we've been here now for a couple of minutes. I'm Richard Stanley. I love games. We mentioned earlier, longtime Square Enix fan. I think when I was doing software architecture, for me, it was about figuring out how I can start to give back to games. So you'll hear a lot about in this that despite the fact that we're talking about AI and manual testing, that keeping people in jobs is sort of like my passion point, and maybe what it makes sense and why we should do that. So moving on from that, I am not the only person here, despite him sitting down, which is weird for me. We have one more person who's going to help us to do the introduction. So you have at least two voices to listen to over the course of the next, what's probably going to be very quick 20 minutes. And I will pass it over to William.
Hi, everyone. My name is Will Baxter. I'm the studio director for Meridian Studios. I run some of our creative teams, some of our planning, as well as work on contracts. So I do a lot of contract writing and working with our legal, which is very, very exciting, as you can all imagine. So who we are. We like to say that we are the biggest little game studio you've never heard of. We're part of a $4 billion company, and we provide white label co-development for most game studios. Any game that you have seen in the last 4 to 6 years, we have probably had some type of hand in from a development standpoint or on the IT side. I can't really tell you who we work with, but you can probably guess based on some of the photos, the controllers. You can make an assumption as to who some of our clients are. So what's our mission? Well, our mission is to maximize value. And that is, to us, being happy with the outcome and the price that you paid. It won't always be the most expensive. It won't always be the cheapest, but you will always be very happy with what the outcome is. It's also to reduce project risk. Something that we take on for y'all. This comes from our background in the consulting world, making sure that we maximize every value, every dollar, and reduce all of that risk. Additionally, team customizability. Unlike other co-dev studios, we can build the team however you want and however we think is best. So there's no bloat. We make sure that it is customized for what y'all are looking for. And a stable talent ecosystem. People are our passion. We are proud to say that we've never had a layoff, and we always listen to our devs to see what do they want to do next, and we put them in a spot so that they can actually do that. Now let's talk about responsible AI, because I don't think that we can talk about AI without recognizing some of the important parts of it. So we like to target the marginalized tasks that have always been and will always be on the outsource block. And manual testing is one of those. It has always gone to the lowest bidder or the lowest priced location. We like to enhance the human capabilities. So we want to accelerate people's learning, and we want to remove the impediments that stop them. We want them to excel where they have passion, as well as acknowledging what the AI limits are. AI cannot do it all, and rushing to the bottom by using AI is not good for anybody, from a developer or a player.
That's it. Now you have to listen to me for all the hardcore stuff. I want to take another minute at least just to at least say that when we say that I think that there are limits to AI, we could kind of talk forever about, like, what if every single thing about every single game was generated by something from an LLM randomly targeted to you specifically? Well, to me, that means that every game is identical in the future. Like, you just log into one place and it spins up whatever thing is there, right? So it's important that I understand that while there are some things that get accelerated and automated, that at some point there's some person there, and we'll kind of talk to that a little bit. So the design vision specifically around this product that we put together and offering, which you'll get to see the architectural diagrams and stuff and all that, is first, it's got to be platform agnostic. So our approach is completely computer vision. It uses YOLO models. I could basically point to any television. The stuff that we'll show you on here was actually initially for the POC was trained on Twitch video, which, I mean, has its quirks, but for the most part still worked, right? Number two, we want it to be human-centered and administered. So at some point, as the AI chain is going through and doing manual testing, there should be some person who can sort of rectify the humanity of what's being tested. There's, I think, an entropy problem with not including human passion and perspective in what's being tested. Like you can export metadata and simulate human thought, but it's not going to come out like Tron. I wish it would. Tron's sweet, but really you're just going to end up kind of going into like a deep learning pipeline hole. That you can evolve the current testing capabilities, so it should do more than it does, right? When you have 1,000 people sitting in a center, running through playtest books, hoping that they hit all the things, checking off the boxes, slamming a bunch of monsters to stay awake and hoping that they hit dandelions. I don't know that AI just replicating that is actually enhancing the feature, so we want to be able to do that. It has to be clearly, if you were in the last talk, cloud efficient and affordable, and maybe you don't need to have $500 million budget to get the game going just because it happens to be on the cloud. So a lot of that is also interoperability. If you partner with somewhere else, we kind of separate where the cloud spend is between us and our partners, and so I would highly recommend you do the same, and we'll get into why. The last two is, firstly, it's got to be self-learning and self-healing. So it should be able to pick up context trends depending on changes in release cycle, and it should be able to, at least on a small, limited scale, be able to solve its own problems, right? If it finds graphical tears, is that a bug, or was that you have an old cell phone? Well, in either case, you really should be able to deal with that, or else the whole system kind of goes under, right? So Barracks is based off of a YOLO computer vision model that pulls off pieces, but obviously you want to decide if that's the best way to go about it for you. So we did do some comparative analysis to similar and different approaches, both in 3D and flat environments. One being LLMs and binary trees as a composed structure, another being world models. For those of you who are familiar with those, I'll be in the hallway, not going to be in this talk. That's like a whole other thing, and I'm happy to talk about them. But the approach that we took at least give us the biggest benefits of the 5 major categories that we wanted to go after that align with the design principles. One being that it has to be platform agnostic and have maximum coverage, that it has temporary memory reasoning so that it has perspective both on what it's doing now and what it did before, that it has sentiment and emotional prediction, which we'll get into before, which nobody tests on. So when we talk about, is the game fun? And you just say, I don't know, but I can log in. That doesn't really help anybody decide if it'll sell, right? So when I say it should do more than it does now, I mean it should do more than it does now, or we shouldn't bother. Also, training cost and complexity should be at least at scale. It should kind of remediate itself to some extent. And the interoperability and extensibility with various systems should be rather basic. It should exist and be in an object-oriented fashion, well decoupled, and not really affect the system it's with. So to date, I still don't need access to your code to test your game. Not with this system anyway. So we'll go through the roadmap. I'll give you a little bit of where we are on the features so that when I'm showing you some of those diagrams, you're like, are you actually doing this? Or are you just talking about it? And the answer is yes, we are actually doing this as a part of our service. The first thing in the 4 phases that we address is what we call agentic automation, which is to combine both classic test automation and a kickoff capability with AI agents. So there's an agent that can play the game, and then what it assesses new types of tests needs to go, whether that's classic smoke tests, integration tests, and things like that that are sometimes done in games and sometimes not. It can kick them off independently and figure out what happened and then make adjustments based off of those outputs. Second phase is what we call player observability, which is, can you observe how players play and then start to learn how to replicate how a player plays? Not in theory, but how they actually would do so by having perspective of how the game itself operates. Also working, and that's a combination of both visual regression as a result of using the YOLO model and being able to play or imitate. Saying, okay, well, if I saw a screen and I knew something about how a game should be, then that should inform how I test. Not because there's just a bunch of logs that come out and then I try to figure out what that means, but that the game itself can evolve into the player what it means. Everybody who's played Mario before can at least take that and say, okay, well, I kind of know how to play Sonic, or I kind of know how to play anything else, right? We shouldn't want to have to teach that to the model every time. And I'll get into how we do that with reinforcement learning. All right, so this is the next two slides are where we're probably 60, 70% there. This particular portion of the feature roadmap has a working POC. We're currently working to engage with a couple of clients that are actually using it, but the point of fact is it does work. And that's player capable. Is it capable of being a player in the same way a player is? Not just replicating a player, but being it and understanding how a player would play. And that's a combination of a compressed RNN skill-based support infrastructure tree, which when we get to the architecture, I'll kind of show you a little bit about how that works as part of our inference framework. And what we like to call omniperception, which is to say, in order for us to really test the game, I should be able to observe it in the same way that a person does. If there's some vein of observability that you can't do as a machine, then you can't really test for it, and you can't really know if the game works, if it's enjoyable, all those things. And then lastly, when this is kind of the alpha beta, we have it in test, but it hasn't been put into production yet, but it is working functionally, is player sentiment and player group persona. So I want to take a second here because this is the thing that's relatively new. In a multimodal way, we are combining devices that track things like heart rate with cameras that can kind of take perception off of an individual who's playing. And when we do that, we can add that to the recordings we use for the YOLO models to figure out whether the person even likes the game they're playing. So we can figure out if they want to keep playing it, if they'd rather be done, if they're starting to yawn, if they wish they were playing anything else, right? You can track the sentiments of that and then put it into the model itself. What does that mean? Well, that means that if you kick it off in a cloud environment and you're rapidly testing the game over and over again, and certain kinds of environments tend to make a player bored, wouldn't you want to know that, right? Wouldn't you want to have an understanding if this type of thing that we're doing is starting to bore me and the system said I did that for 6 hours last night? Well, then probably they're not going to want to play the game. And right now, manually test doesn't really tell that to you. So that's what we want to really focus on. Okay, so now I'm going to kind of go over the behavior features and some of the test automation features right before we get to that actual sort of like meat and potatoes portion of architectural diagrams, which I'm sure everyone here is just, to get those diagrams. You get the phones out for those. But, and it's, it's pretty basic. We have to make sure it has detailed logging because for anyone to use it, we need to be able to integrate that with other places. So right now, it takes all the logging features, pipes them out to JSON files, and just throws them into Jira or wherever else you feel like you need to have those reporting on. We do have fancy screens and stuff like that other places, but from what we can tell, most places have their own. We have to be cloud agnostic and tool agnostic, so it doesn't make a whole lot of sense for me to write a tool that you're never going to use. It's got to have robust shopping. Now, that sounds very strange, but we call it that because in a lot of games, and I played a lot of RPGs, like I would say probably other than like Elden Ring, Night Rain, I have more hours than any kind of RPG ever. Most of it's shopping. It's like taking money, currency, or some kind of resource, and then going through a bunch of menus and deciding how to use that resource, right? And that's how I know I probably should have been an analyst because I enjoy that stuff, which is boring to most people, but I guess some people like it. So most of the things where you're not controlling a person is shopping. You're shopping or you're moving, right? So we need to have robust shopping. Playstyle customization is a must. Meaning I need to understand that every person in this room probably plays the game slightly differently, likes things slightly differently. And I don't need to necessarily change the game for that, but I should know if you like it. And if most of you don't like it, that's probably a problem. There's, I think, something to be said for over-individualizing a game experience in that it stops people from being brought together. Like most of the people in this room played games, and they know people who played similar games, and you like that you can talk about similar games. But if everybody's experience is totally different, what are we going to talk about? What we ate last night? Like, I don't even know. Last, robust strategic analysis. It kind of goes along with those other portions to say, like, look, if I can't get output from this to tell me where to go, it doesn't do me any good, right? So currently, and you'll see some TFT screens on here. We did originally develop this in conjunction with Riot Games. They know I'm here. They know I'm showing you these. I didn't have to tell the lawyers. It's good. TFT, if you haven't played, it's top down, there's purchasing, has robust shopping, all those things we're looking for. But it has test assertions, automation verification, screen comparisons, historical strategy, percentage-based object identification. I'm not going to read the other bullets. You guys can see them. It's got stuff it does, right? Okay, so, and I'm keeping an eye on the clock here. We're good. The last thing is that the logging itself is live interoperability. So you can actually see the agents playing if you want to. You can kind of intervene with the agents and try and figure out what's going on. And the way we've done it is it just kind of goes through Python and creates an overlay. I would recommend, having some ability to kind of see and peer into when you guys take a look at the framework. I think just kind of setting it off and going home in the evening is a little bit hoping for much. So it's important that you have some way of seeing what's going on, and we can view that. Lastly, those automation capabilities, it can independently run, the agents themselves can independently run new tasks to go through repetitive UI verification tasking, record and assess specific test requests, manage those testing types, like I said before, for smoke test, integration, multiplayer infrastructure, all those kinds of things that need to be tested independently and can be done without spinning up an entire other agent structure, and then providing infrastructure and integration functions along with that. So, okay, this is where we start getting into it. So it's important to note that we did everything we could to use open source technologies because I should be able to pick this thing up and deploy it in any cloud environment. It shouldn't matter because our clients are diverse and they have their own opinions. One of the things you'll notice here is that we kind of separate between where we choose to store the different software. And this is obviously not a hardware layer. The cloud infrastructure is next. We put everything inside that blue box there on our infrastructure, and then everything inside the purple box typically is within the software hold of our end clients. Why is that? Well, tenting is kind of a problem, right? So the first question we got asked was, we get that you guys don't want to plug into the code, but what if we're playing a game you've never seen? What if we're worried about leaks? Those kinds of things. Some people don't care. A lot of places care. So having a conjoined cloud environment that lets us access their models means we can run this infrastructure on that model without having to look at the model. I don't even necessarily need to know what game that is. It just has to be there. And the system will look at how that game is structured and run it on its own. Now, the center portion of the inference framework is what the next slide is about. And I want to talk a little bit about it because that's the custom code that we write on our side, right? So we've developed, and I don't think it's unique, but it's the approach that we use, something that I like to call micro-reinforcement neural networks, which means that it extracts perspective on a micro level. I'm not the biggest fan of LLMs, and I can say that out loud because it's sort of like jamming the whole world into a space and asking it to describe a peanut. Like, it doesn't need to know all that, and so it has a tendency to be pretty bloated. I think this approach allows us to separate into specializations, right? Like, I want a model that's really good at Python, and then I want someone to ask that model to make me Python and not have it always there all the time. There's a lot of smart people, but having too much stuff and even a human brain can have its own issues, and it uses a lot of CPU usage. So we separated it out by clusters of smaller neural network trained specific tasks for different reasons, so it can understand a specific thing like, what kind of game type is this, right? It can look at the video and say, it looks like this is an RPG, or it looks like it's a sports game. Now it has perspective on a sports game that eliminates my need to tag that particular type of information for the YOLO model output. It understands goals and will separate it into things like, should I get XP in this game? Should I get money? Is it characters? Am I going for a score? And the more of those kinds of things that we can add to that tree on our side, then every time we pick up a brand new game, even if we've never seen it before, it starts to know on its own the same way we've all played Mario, right? Or maybe not everybody. If you haven't played Mario, that's fine. Great. So what does that mean? It means that that separate central area can do its own learning on multiple different types of games and perspectives at all times. And that's kind of, to be fair, why we have a benefit as a company, and that we can kind of get this library of perspective and give it access to anyone who wants to use it without having to retrain. Okay, so the cloud environment itself is specifically bifurcated for the same reasons I said before. And this happens to be AWS specific. I get that. It's just easier to get their icons, to be totally honest. And when we did this for Riot, that's what they happened to be using. But there isn't a single part of this that could not be swapped out for Azure or for GCP. And that's what's important here. I don't feel like I've done anything amazing, but you can look at it and you can say, okay, so we could set this pipeline up. And it's like, yeah, absolutely. And there's still people in between. We feel like having at least some limited amount of human facilitation is important. So the end goal for us is to be able to provide some kind of limited amount of physical game testers who can be diversified in any way you want. And we talk about that in terms of the persona capability. When I talked earlier about having IoT devices and things that are attached, that also kind of releases you into saying, well, what if I want to know who somebody in a female who's 45 years old who lives in Germany, how do they play this game versus a 22-year-old who's living in the UK? Isn't there a difference? Shouldn't we care? You can get that by changing up, instead of having large scale testing individual, you could just have like 2 weeks with one place, or you could bring in some community, or you could get something pre-alpha and just take that video output. So that kind of gives you the separation there. Last couple of quick slides we'll go through here is just the test framework overview. This lets you see that there's devices that we can interconnect with, whether we have our own testing block for PS4s and the kits and things. We actually have Arduinos that simulate controller input that go along with the rest of the stack, so they play the console. They don't try to simulate it. That's how we do it. And then the last information slide here is just, does it work? But yeah, it does. Even when it comes down to the classic approach, where how would you go through saying, hey, you've got QA requirements, what are they? We see retest rate reductions of 70%, defect leakage down 82%, and then 99 MTTR, because honestly, it runs itself so many times in a row. If after that, there's still something that's hard to see. But most importantly, down are additional untracked KPIs that you can't see, right? Before, we wouldn't know things like user retention rates and session length and loop frequency because there's no way to simulate that. Through computer vision, that's possible. So, yeah, that's it. Here's the information for us if anybody wants to bug us online, and appreciate your time today.